morning students, welcome to our student center. So today our topic of discussion is geometric progressions. Before starting discussing geometric progressions, first of all we will take a review on the topic arithmetic progressions. What is arithmetic progressions? Arithmetic progression is a sequence of the numbers with having the common difference. Means if the difference between the ABs, suppose if we form an arithmetic progression AB series, if we form AB series like this one, that is 2, 4, 6, 8 and so on. So I have made the series, we have made a series of numbers, that is 2, 4, 6, 8, and we have taken the series of the even numbers. And so in this series, the difference between all the numbers, the difference between all the numbers, the succeeding number minus the preceding number will be same, always the same. The difference between the numbers is same. So AMIT'S arithmetic progression are the series in which the difference is same in all the numbers given in the series. The difference is common. So we have and some terms are given in the arithmetic progression. If we have to calculate the sum, or we have to calculate the an, and difference. An and n are the last terms. An is the last term. In the AB series, we will include first number as a1. First number is taken as a1. Second number is taken as a2, and third number is taken as a3, and so on. We will continue by all these. And the last term, we don't know. This will be taken so many terms in the arithmetic progression. So an is the term which is last term. This is the last term which is equals to n, which is given here. And last term, an is the last term of the AP series. If we continue by writing all these numbers, and there are so many numbers, and we have to calculate how many terms can be taken in this AP series. That is, if we have to calculate the n. N is the number of terms. Okay, in the AP series, which is given to the AP series, how many terms can be included in these AP series? That is the n, and D is the common difference. And there are two formulas given in the AP series, that is an is equals to a plus n minus 1 d. Okay, that is if we have to calculate this formula is given. If we have to calculate the last term an, we have to calculate, then we will calculate by using this formula. And if we have to calculate the sum of terms, so if we have to calculate the sum of terms, the formula is given to be sum of terms, which is Sn to be calculated is n upon 2a plus n minus 1 d. D is the common difference, n is the number of terms which are included in the AP, and a is the first term. If we will take a1 and a, both are the same terms. And if we have to calculate the next terms, then we will use the formulas. A2 is equals to a plus d, a3 is equals to a plus 2d, a4 is equals to a plus 3d, and so on. We will continue by taking all these terms. For the same, if we have to calculate for the GB, these are for the AP, the arithmetic progressions. If we have to calculate for the GB, if we have to calculate the last term, number of terms in the GB, the difference it is not given. The difference is in the AP series. Difference should be calculated, that is a2 minus a1, or a3 minus a2, or a4 minus a3. Means the succeeding term minus the previous term. Succeeding term minus the previous term, you can easily calculate the difference. The main fact of the AP is that the difference always remains the same in the arithmetic progressions, and same it is in the geometric progressions. GP series it will be also same, but here also a series should be given. That is, suppose I am making the same series this common ratio should be taken. Common ratio, that is R first term is equals to A. In the arithmetic relation, the common difference is taken here. Common difference is taken here. The common difference is taken, and in the geometric relations, common ratio is taken. First term is A, and if you have to calculate the AN, it should be ARN minus 1. The formula for the AN should be AN is equals to A plus ARN minus 1. If we have to calculate, first of all, if we have to calculate the common ratio. First of all, we will calculate the common ratio. R should be, first term is given, and R should be A2 by A1. Here difference is calculated A2 minus A1, and here the common ratio is calculated A2 minus A1. A2 minus A1, A2, the A1, A2 and A1, A2, A3 are same as it is in the arithmetic progression. First term is A, second term is A2, third term is A3, fourth term is A4, and so on. So here A2 is 4 and A1 is 2. The difference is same, that is 2. And similarly, if we have to calculate another difference, that is A3 by A2, the difference will again same, 6 by 4, that is 2, 3. Here the common ratio is calculated. It should be the same common difference, and then if you have to calculate the next term, in this, if you have to calculate the next term, suppose in the arithmetic progression, if you have to calculate A3, its their formula is A plus 2D. But here in the geometric progressions, if you have to calculate A3, it should be A R square. That is AN is equals to general formula. I am writing the general formula. General formula to calculate AN. To calculate AN is equals to A R n minus 1. Here to calculate the value of AN, it should be AN is equals to here n is the number of term. If you have to calculate the third term, fourth term, fifth term, or last term, you can put here the value of n. If you have to calculate the third term, then you can put n is equals to 3. 3 minus 1 is 2. The formula will be A3 is equals to A plus 2D. But here, if you have to calculate the number of the terms, suppose again if you have to calculate the third term, then we can say that here we will put n is equals to 3. A is given to be 2, and R is also given to be, R is the common ratio, that is 4 minus 2 is 2. Then we can put here the values A3, n is equals to 3. If you have to calculate the third term, A3, A is 2, R is 2, n here is, n is 3. 3 minus 1 is 2, that is 2 square is 4, 4 to 8. So third term is 8. So by using this formula, you can easily calculate the value of AN. And now if you have to calculate the sum, let us suppose if you have to calculate the sum of these ratios, 2 plus 4 plus 8 plus 16. Then if you have to calculate this one, the ratio would be same. Ratio, common ratio is any of the terms. And here A2 by A1, you can divide any of the term, or A3 by A2, or A4 by A3. You can divide any of these terms to calculate the common ratio. So the common ratio would be 2, and here the first term is also 2. So if you have to calculate the main general formula. Here, this if you have to calculate the sum in AP progression, arithmetic progression, its formula is n upon 2, 2a plus n minus 1t. And if you have to calculate the common ratio, if you have to calculate the sum of the n terms in the geometric progression, then its formula is a r power n minus 1 upon r power n minus 1. Here, if you have to calculate the value of n, sum of n terms, if you have to calculate the sum of any 3 terms or 4 terms, let us take suppose in the, here the general formula is sum of n terms. If you have to calculate the sum of 4 terms as given in the question 2 plus 4 plus 8 plus 16, then you can calculate it by formula as 4, which is equals to a. A here is 2, r here is again 2, and n here is 4. 4 minus 1 upon 4 minus 1, which is r power 4 is 16. 2 to 4, 16. 16 minus 1, 16 minus 1. Here 2 multiplied by 15, which is 30 upon 15, that is equals to 2. So sum of 4 terms here is S4 is equals to 2. So by using these two formulas, I am comparing the arithmetic progressions and the geometric progressions. In this, first of all, we are discussing the difference between these two arithmetic progressions and geometric progressions. I am again repeating formula for AN is this one for arithmetic progressions, and for the GP it will be AA. For the GP, AN is equals to A R n minus 1. Writing here the formula. Okay. For the GP, the right hand the formula is AN. For the AN is this one, and for the sum of GP geometric progression, the formula is here A r to the power n minus 1 upon r to the power n minus 1. For the sum of n terms in the arithmetic progression, so it will be n upon 2 2a plus n minus 1 multiplied by 50. Now we will continue with our questions. In this question, we have to find the sum of the first 5 terms, and GP here is given to be 1 plus 2 by 3 plus 4 by 9, and these series are given, and you have to calculate the sum of first 5 terms. Okay, to calculate the sum, first of all you have to divide as a is given to a is the first term of GP, that is 1 is given, and difference and the common ratio, which is a2 upon a1, that is 2 upon 3 upon 1 is 2 upon 3. So the writing the formula of the sum of GP, sum of 5 terms. I am writing the formula Xn is equals to a 1 minus Rn upon 1 minus R. If you can calculate formula same, you can also write a Rn minus 1 over R minus 1. The formula is the same. You can write it any way. Either you have to write 1 first and then Rn, or you have to write Rn first of all, then write 1. The formula is the same. So writing the sum of the first 5 terms, here the a is given to be 1 and 1 minus R. again multiply this next term with the common ratio, you can get how many terms, but we have to calculate how many terms to get the sum of this. Sum should be given. The formula of sum is S. M is equals to A 1 minus R power N upon 1 minus R. This is the formula of the sum. We have to calculate the value of N. And A is here given to be 3, and ratio is given to be 3 upon 2 upon 3 upon 1, which is 3 upon 2, 1 upon 3, that is 1 upon 2. The common ratio is 1 upon 2, and you have to calculate the SM value of SM is given, that is 3069 upon 512. To calculate the value of the N, you can put all the values here, then you can calculate it. 3069 upon 512, and A is here given to be 3, 1 minus R here is given to be 1 upon 2 power N. You can take it N because we don't know the value of N, and 1 minus 1 upon 2. Solving these equations as much as you can. It will be 3069 upon 512, that is 3, 1 minus 1 upon 2 power N upon 2 minus 1 is 1 upon 2. By reciprocating the equation, this is 1 upon 2, this will be 6, 1 upon 2 power N. So 3069 by dividing these equations, that is 3069 upon 512. If you will here the ratio is 3069 upon 512, and this 66 is multiplied by this, and by taking this 6 here, it will be divide 516. This will be 3072, which is equals to 1 minus 1 upon 2 power N. So by cutting these equations, it will be 1 upon 2 power N, which is 1 minus 1 upon 2 power N. So 1 should be written in any form, that is 1 minus 3069. So here, if you can take this one on the other side of the equation, that will be minus 1, and then you will take here the value of N will be any one, that is 1, 2, 3, 4, any non-zero value will be of the N. So here that 1 power 2 is also 1, 1 power 3 is also 1, 1 power 5, 6, 7, 8. The value of 1 is always remain 1. So we can take the value of 1 upon, because it will always remain the 1 by getting any power, by getting any value of N. So we will take here 1 upon 2 power N, and here we can take the LCM. 3072 minus 369, here 3072 minus 3069, here it will be 1 upon 2, and by subtracting this equation, it will be 3. Here it will be 3, and by calculating these equations, you can get the value of 2n is equals to 1024, and by solving here, this 1024 can be written as 2 power 10. 1024 can be written as 2 power 10. So by equating the values of n, by equating the powers, you can get the value of n is equals to 10. Okay, so moving on to the next question. In the next question, first of all, the question is given to me the fourth term of GP. The fourth term of GP is square of its second term and the first term. First term is A, which is given to me minus 3, and we have to calculate the value of A A4 should be written as A R power 3 and A2 should be written A R square. Okay, by squaring here it will be A square R square and here it is A R cube. A square should be cancelled with this A. Here it is left only A and square should be cut down with this cube. Here it will be R. So here one relation comes out which is very important relation, that common ratio is equals to the first value of the GP series and first value in this question is given. So the value of R is also comes out to be -3. Now we will put the values of A in this equation A7 and calculate the value of A7. A7 will be A value of A will be -3 and R will be -3 power 6. So -3 multiplied by -3 multiplied by -3. It will be -3 power 7. Okay. So 3 3 are 9. 3 3 are 9. 3 3 are 9. 9 9 are 81 and 81 3 are 243 and 243 multiplied by 3 it will be 3 3 are 9. 9 3 are 27. It will be 9. Here it will be 9. 81 multiplied by 9. 729. Again we will multiply it with 3. 9 3 are 27. 6 7 8. 2187 minus 2187. For minus minus plus plus minus minus minus. This will be positive positive negative 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 positive positive negative 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 positive and here positive negative will be negative. So value of A7 will be minus of 2187. Moving on to the next question. In the next question it is given that the 5th, 8th and 11th term of GB are P, Q and S respectively and we have to show this Q square is equals to PS. In this question we don't have to find any term, just we have to prove the relation that Q square is equals to PS. Okay, so by writing the same formula, AN is equals to A N should be A R N minus 1. So here N value, A fifth value will be A R 4. The value of fifth value is P respectively. P is equals to A R the power 4 is given as a question and by continuing the same A 8 is given to be A R 7 and value of 8 term is Q. So the value of Q is A R power 7 and the value of S is equals to 11th term. A 11th is equals to A R power 10 and 11th term is equals to S which is equals to A R power 10. So I am marking here the star. By using these three equations we can solve this question. The relation is here is given to be Q square is equals to PS. By putting the values here, the value of Q is A R power 7 and in the relation we have to use its square. Okay, and the value of P is A R power 4 multiplied by S A R power 10. So by squaring here it will be A R square is equals to R power 14. Here multiplying here A square is A multiplied by A is A square and R power 4. When the bases are same, powers get added. So R is 10 plus 4 which is 14. So A square is equals to R 14. A square is equals to R 14 and A square into R 14. Left hand side is equals to right hand side. So this equation holds. We can say that Q Q square is